Our last video for section 4 is actually going to talk about how do we find the equation of a tangent line. So to find the equation for a tangent line, we need two things. And this is, you should write this down, you should circle it. This is very important for the entire class. We need a point, we need to know the coordinates of the point, and then we need to know the slope of the tangent line at that point. For our difference quotient, it means the limit as h approaches 0. And then we're also going to add something called a normal line, which is simply perpendicular to the tangent line at the same point. A little picture might help. Let's say we were looking at a function that looks something like this, and extend that out a little bit. Let's say this is the point that we're interested in. So our tangent line in red would go something like that. And if we knew the coordinates of this point, let's just call them x sub 1, comma y sub 1, and we knew the slope of the tangent line, we figured out that that was m. Okay, the slope is m. So we have a formula from Algebra 1, which would be, let's see, what was that again? That is y minus y sub 1 equals m times x minus x sub 1. And the way that I usually use this now is y equals m times x minus x sub 1, and then add the y sub 1 at the end. So we know these three things. We know the coordinates, both parts, and we know the slope, so we just plug them into the right point, or the right parts of that formula. And then also the new thing would be the normal line. The normal line is simply perpendicular. Oops. It started to come through there. It's perpendicular to the tangent line. It's going to go through the same point. And so our job really is to find the slope of the blue line. And remember that if lines are perpendicular, these two slopes would have to multiply to -1. So if I know that this is a slope of maybe -1/3, this would have a slope of 3 then. And we can still use the same overall equation to actually come up with the equation. Okay, let's go through a quick example. So our equation for this is 1 over x plus 1. You can graph that on your graphing calculator if you want to. We're going to come up with a general formula to find the slope of any tangent line at any x value. And then in particular, we're going to look at x equals 2. To start off for part A, we're going to use our difference quotient and set it up how we've learned to in the previous video. So remember, as we set this up, we're going to first plug in an a plus h for the x in the function, so I get this. Then we subtract f of a, so I plug an a in for the x, and then everything is divided by h. Now, to me, that looks really complicated, so sometimes I will just rewrite it and maybe simplify it a little bit. And so I took the entire numerator and just wrote it out front, and then instead of dividing by h, I multiply by 1 over h. Same exact idea. This makes it a little bit simpler because now I can just work on trying to combine those things. If I want to combine fractions with addition or subtraction, that means I need to come up with a common denominator. Oftentimes the easiest way to come up with that common denominator, you simply write both parts in the denominator, but now they are being multiplied together. So for the first fraction, if I'm going to put an a plus 1 in the denominator here, it also has to go in the numerator. So I would have an a plus 1, really times a 1, right, times the 1 that I had right here, but it's not going to matter for this one. And then I'm going to subtract whatever the other numerator would have. And so for this one, instead of just a plus 1, now I'm going to put this denominator in the bottom, and so that denominator, this new one, would also have to appear in the top, multiplied by 1. Again, not going to matter for this particular example. So I have an a plus h plus 1 in the top, and then remember to write everything down, I still have times a 1 over h at the end. And as I continue to simplify this, I'm just going to distribute this negative symbol to all three parts over here, and lots of things are going to start canceling off. So I have a positive a and a negative a. I have a positive 1 and a negative 1. Those are gone. And so my entire numerator for this part is now just a negative h. So I have one chunk that's a negative h. I have all of this in the denominator, and then I'm basically dividing by an h or multiplying by 1 over h. And so because this chunk and this chunk are kind of related, as a secondary step here, the h's will cancel off. Just keep in mind that the negative symbol right there is still very important. So really, instead of just being a 1 there, it's a negative 1 in that numerator. And so in the end, I would have the following. And now I'm at the point where I can actually plug in a 0 for any h that is left over, because if I plug in a 0 right there, I still have stuff in the denominator. So in the end, now I do the substitution, I don't need to write limits anymore. I just have negative 1 over a plus 1 times a plus 1, or really just negative 1 over a plus 1 being squared. Okay, and this is good for any x value that I'm interested in for this particular function. As far as finding the slope of the tangent line, in particular, I'm curious about what's going on at x equals 2. So to find the slope of the line at 2, I'm going to plug a 2 in for the a right there. So I would have negative 1 over 2 plus 1 being squared. And so my slope for this would be negative 1/9. So we now found the slope at the point that we're interested in, and now we can go ahead and start writing our tangent line and our normal line. So part C says write the equation of the tangent line at x equals 2. We need to know two things for this to work out. We need to know the point, and so our x value is 2. If I go ahead and I plug a 2 into the original function, that tells me that the y value there would have to be 1/3, I believe. So that's my point, and I know that the slope from what we did in part B is negative 1/9. And so remember that point slope formula that we talked about. Our tangent line would be, here, let me write down our formula here a second. We have y equals m times x minus x sub 1 plus y sub 1, just so that's written down there. Slope of our equation for a tangent line would be y equals our slope, which is negative 1/9, x minus 2 plus 1/3. Okay, that's our tangent line. Normal line is going to go through the same point, still 2 comma 1/3, but the slope has to multiply with our original slope to get a product of negative 1. So it means the slope for the normal line is a positive 9, and so for that we just have y equals 9 times x minus 2 plus 1/3. That is it for this section of notes. I would challenge you to maybe graph the overall equation and look around x equals 2 and kind of make sure that these two lines make sense, and if that's not the case, if it's not really making sense to you, jot down a question and come ready to ask it in class tomorrow.